We can continue our work with isosceles triangles. And again, it's very important that you recognize, particularly today with what we're going to talk about, what the pieces are called. So the two congruent sides are called the legs. The vertex angle is the angle that is between the two congruent legs. And then the base is the third side that is not congruent, and then your base angles are the angles that are formed between the legs and the base. So when you look at number one, you have some information. Now, in this particular case, I can't say like I did yesterday where you have two base angles that are congruent and you can set them congruent. I don't know that anything is congruent because what I know is that this is congruent to this, but I don't know how big that is. Now, I do know, though, that if those two have to be the same size, then this angle right here has to be 2x. Unfortunately, you can't set those two equal to each other because then that doesn't help you solve anything. But what I do know is I have to go back to the angles of a triangle, add to 180 degrees. So I can say 2, 4, 6x minus 24 is equal to 180 degrees. So if I take 180 and I add 24 to both sides, divide both sides by 6, I get that x is 34. Let me write some of that down. X is equal to 34. And I went back to the angles of a triangle, add to 180. Now we want to do the same thing on number 2. And if you look, we've got this blue triangle here. And then I've got this red triangle over here. So we want to see what we have the most information with. Well, with this one, we have our base angles. So both of these are 6x plus 18. Now, again, it doesn't do me any good to set those equal to each other. I don't have the base angles of the red triangle, and those don't move over because we don't know that the lines are parallel. But what I do know is that vertical angles are congruent. Linear pairs are supplementary. Vertical angles are congruent. Triangles add to 180. Those are three things that you will just use all the time. So now I have all three angles of that blue triangle, and I can set it up that 6x plus 4x plus 6x is 16x plus 36, those two, combining those two 18s together, and that equals to 180. So 180 minus 36 is 144. Divided both sides by 16, and you get that x is 9. Now, in the next 4 problems, you don't have a triangle. And when we're talking about triangles, it's really helpful to have one that you can see. So if the base angles of an isosceles triangle, so as soon as I see that, I'm going to come over here. I'm going to draw an isosceles triangle so that I can see it. The base angles measure 3x plus 8 and 12x minus 28. What is the value of x and the measure of the vertex angle? So based on that, I have my two angles. I know that my base angles are congruent to each other because the legs are congruent to each other, which means that 3x plus 8 is equal to 12x minus 28. So if I subtract 3x from both sides, I get 9x. If I add 28 to both sides, I get 36. And if I divide both sides by 9, I get that x is equal to 4. So that's part of it. What's the value of x? Then it says, what's the measure of the vertex angle? The vertex angle is this angle up at the top between the congruent legs of the isosceles triangle. So we need to find out what the base angles were. So if you do 12 times 4, because it was 12 times x minus 28, subtract 28, you find out that this angle is actually 20 degrees. If that one's 20 degrees, so is this one. So those two angles together are 40 degrees. If I subtract that from 180, then I get that the vertex angle is 140 degrees. If an acute angle of an isosceles right triangle, so as soon as we know what we're drawing, an isosceles right, remember that's a right triangle, which means it has a right angle. It's isosceles, which means that two sides are the same length. So the acute angle is 2x minus 15. So all you've been given is one of the angles. Well, because it's isosceles, we know that this one is also 2x minus 15. Now again, it doesn't do any good to set those equal to each other because they cancel each other out. But I know that those two isosceles triangles have to add to 90 degrees because the whole triangle has to add to 180. I've already used up 90. So I'm going to add those two together, 4x minus 30. I could say plus 90 equals 180, or I can skip straight to equals 90. Those two angles together have to equal 90. So I would take 90, add 30 to both sides, divide both sides by 4, and I get that x is equal to 30, which is what the question asked for, so I'm finished. If triangle ABC is isosceles with a vertex angle of A, so we need to come over here, we need to draw the picture. Vertex angle is A. It doesn't matter where B and C go after that, but I know that AB is congruent to AC based on the information that I was given. So the vertex angle is 2x plus 40. The base angle, one of them, is 5x plus 16. I wasn't given C, but I do know that C has to be the same size as B. Well, I don't have two separate values for B and C, so I can't set those equal to each other, so I have to use the triangles add up to 180. Remember back when we did segment addition and angle addition postulates, we said it was either part equals part, or it was the sum of the parts equals the whole thing. And so that's what we're doing now, is the sum of the parts is equal to 180 degrees. So I have to say then this is also 5x plus 16, because that's the only way I can set this up. So I know that if I combine my like terms, 5x plus 2x is 12x. 16 and 16 plus 40 is 72. And I know that all of those angles have to add to 180. So I shortcutted it, but just so you're clear, I did 5x plus 16 plus 5x plus 16 plus 2x plus 40 equals 180. That simplifies down to 12x plus 72. So I take 180, subtract 72 from both sides, and then divide both sides by 12, and I get that x is equal to 9. That answers part of the question. The rest of the question is, what's the measure of B? Angle B was 5 times 9 plus 16, so 45 plus 16 is 61 degrees. So angle B is 61 degrees. So you have to, when you set it up, you have to decide, are the base angles equal to each other, or do all the angles add up to 180? Those are your two choices in all of these problems. Now the ratio of the measure of a base angle of an isosceles triangle to the measure of the vertex angle is 2 to 16. We did a problem like this where your expanded ratio was 1 to 2 to 3, and we always draw a picture. We know where our vertex angle is. So it was the ratio of the base angle to the vertex. So it's the base angle to the vertex. So the base angle gets a 2x and the vertex angle gets a 16x. Now, again, I don't have angles that I can set equal to each other because these are the two angles that should be equal to each other. But I do know that this angle has to be 2x because it's also a base angle. So then I know that 2x plus 16 is 20x, and those angles all equal 180 degrees. That came from this. Let me back up just a little bit. Okay, so that's where that 20x came from. So 180 divided by 20 is that x is equal to 9. If x is equal to 9, then each of these angles are 18. And 16 times 9 is 144. If we do a quick check, 144 plus 36 is 180, so they check out. So the measure of each angle is, the vertex angle is 144 degrees, and the base angles are each 18 degrees. So you need to be sure that you always draw a picture, always know where your vertex angles and your base angles are, and then be able to set up, are they equal to each other, or do they add up to equal 180 degrees?